Everyone, today we are going to discuss the process of infix to postfix expression conversion. So let us start with this. So before going to the conversion process, this is what is an infix expression looks like. So this is an infix expression where you can see that how it is infixed, because we can find the operators which are like this plus and multiply. They are inside this operands 4, 3, and 5, and this is how a equivalent postfix expression is being converted, where the operators like this plus and multiply, they are after the operands. They are not in between the operands, they are after the operands, like this. After this 3 and 4 we have this multiply, and then we have 5, and after this 5 we have this operator plus, which is coming in the end. So this is something which is like a postfix expression. There are further examples like this. This is the infix expression, and its equivalent postfix expression is this. Then we have this as the infix expression. Then we have this as the equivalent postfix expression. So these are the examples which are being used to make sure that how the infix and postfix expressions look like. Then we have something which is called as precedence of operators. So when we are evaluating or ultimately converting the expressions, we need to identify the precedence also, based on which the algorithm will work. So this is various operators, arithmetic operator generally, which we find in the infix expressions, arithmetic expressions. So this is plus minus, this is caret symbol, and this is multiply and divide. This is how the precedence will go. Precedence means if plus and minus is there, so it is having low precedence as compared to this caret, and very low as compared to this multiply and divide. And reversibly also, multiply and divide is having higher precedence over these three operators. So based on this, we have to perform the conversion of this infix to the postfix expression. So coming to the algorithm, this is how the algorithm looks like. There are certain rules to convert the infixed string to the postfix string. So we have to start evaluating the infix string from the left hand side and inspect each and every character of the given infix string. That is the first rule. Then there are certain algorithm steps which we have to cover. So these are the steps which we have to cover. First thing is, if you find a operand, operand is like in the previous expression, 3 plus 4 divided by 2. That 3, 4, and 2, these are operands, or the values on which we are going to perform the operations or applying the operators. And there can be brackets inside those infix expressions, which is starting bracket, and this is like ending bracket. So based on this, you have to evaluate this expression. So expression can have operands, brackets, and operators. So based on this, this algorithm is being designed. So if it is an operand, then append it to the end of the postfix string. So postfix string is basically our output string, which we have to ultimately find out. And if there is a opening bracket, so then we have to push it onto the stack. So this is the algorithm which is being governed by use of the stack data structure. So stack is being used in which the elements are pushed and popped out to perform the operations of infix to postfix string conversion. So we are going to use the stack data structure. This can also be said as the application of a stack, where the stack is being used to perform this type of conversion. Then if we find a operator and if the stack is empty, see, the rule is that if we find an operator and if the stack is empty, then we can push that onto the stack. Else what we can do is we have to pop the operators of greater or equal precedence from the stack. So now the precedent rules comes in. Suppose like if we are performing the operation 3 plus 4, okay, so 3 plus 4 will give us a expression which is 3, 4 plus. Output will be 3, 4 plus of this infix expression converted to postfix. This is the output. So 3 is basically an operand. So the first rule will be applied while processing this. So if it is an operand, so we have to apply or append it to the postfix string. So this will be our postfix string, which is 3 4 plus. Okay, so postfix string is 3 for this 3 plus 4. If we find a bracket, so there is no bracket inside, so this rule is not applied. Then we have this plus operator, which is the next character in the infix string, which we have to convert. So plus is an operator, so that means this third rule is applied if the stack is empty. Right now our stack is empty, so this plus will be pushed onto the stack. Otherwise we have to go with this particular else part. In case stack is not empty, then this complete else part or any of the things in the else part will work as per the choice or as per the feasibility. Then we have the operand again. Again, a operand is encountered, we have to append it at the end of the postfix string. So our postfix string will become 3 4 like this. Then we have this plus operator, which is left behind inside the stack. So it will be cleared by use of this rule. So as our string 3 plus 4 is over, infix string is processed. So when the end of the infix string is reached, as per the rule number 5, pop the remaining operators of the stack and append them to the postfix string. Okay, so this plus will be popped out and appended to the postfix string end. So final outcome will be this as the postfix string 3 4 plus, which is the same thing. Okay, so this is how the infix expression is converted to the required postfix expression based on these set of rules. So suppose there is some expression in which the brackets comes in, so we have to follow the rules like this. If suppose there is a bracket like this opening, then we have to push this onto the stack. And similarly, if there is an ending bracket, then we have to pop the operators of the stack and append to the end of the postfix string until we encounter this opening one. And when opening one is encountered, this is also popped off from the stack. So this is the basic algorithm. Then in case operator is there, but the stack is not empty, in that case, this else part will work for this third step. Okay. So in third step, what we do, if operator is there and the stack is not empty, in that case, we go to the else part and start to read these statements or execute. So pop operators of greater or equal precedence from the stack means if we find operators which are of equal or greater precedence inside the stack, then we append them to the postfix string. Means if we find a operator of greater precedence, suppose plus is going to be processed and inside stack we have division operator. So this is part of my stack division, and this is infix string. This plus is part of the infix string character which has to be processed right now. So first plus is processed right now. So we come to this step 3. It is an operator. So pop operators of greater or equal precedence from the stack and append to the postfix string. So this division is basically part of the stack and it is of greater precedence than this plus as per our previous precedence rules, which is given there. So as per this, so this division should be removed and added to the postfix string end, and this plus will be replacing it in the stack. Okay, plus will be moved to the stack and this division which is of higher or equal precedence, it is moved to the end of the postfix string. This is how the operator case will be encountered in case we find the stack not empty. And when we have to stop removing elements from the stack, when a opening bracket is reached or a operator of lower precedence is reached or the stack becomes empty. So we have to keep on popping the operators of greater or equal precedence from the stack until unless we find a opening bracket inside stack, or a operator of lower precedence is encountered, or the stack becomes empty. In either of these 3 cases, we have to stop popping the operators from the stack. And then finally, we have to push the operator in consideration onto the stack. So this is done in case lower precedence operator is initially figured out also. Means suppose there is no division, there is minus. So minus is also of equal precedence. So this case will work for minus also. But if we find a operator which is of lower precedence, basically in case of multiply, divide, minus, plus minus is having lesser precedence than this division and multiply, so there is not that case. But suppose if there is a caret operator which is in there and division operator is encountered, or we can reverse this thing. Suppose incoming operator is division and inside stack we have plus. So when division is encountered, we come to case 3, but we have to pop operators of greater or equal precedence from the stack. So this plus is having lower precedence than the incoming operator, which is division. So what we do in that case, push the operator onto the stack. That means this incoming operator will again be pushed onto the stack after this plus. Okay, so this is how this rule 3 works. So let us test it with the help of a example, and then it will be more clear. So this is the example for infix to postfix conversion. So this is our given infix string, which we have to convert into the postfix. So this is the final outcome of this particular infix to postfix conversion. So this is the table which will be used to perform this evaluation and give us the result. And what we are storing inside this is unprocessed infix string, means one by one we have to scan the characters from left hand side of this infix string and move some elements to the stack as per the logic, and move some elements to the postfix string, which is the final output. And we are also indicating which rule of that algorithm which we have discussed right now is going to be used inside it. So let us start with this. So this is our unprocessed infix string to start with. Initially stack is empty and postfix string is also null. And rule used is hyphen because we haven't processed anything yet. So next we have to start with this 7 now, which is the leftmost character inside the infix string. So we start with 7. So 7, as 7 is an operand, so rule 1 will be applied. Rule 1 says that when operand is encountered, we have to push that onto the postfix string. Okay, so that is how 7 is entered to the postfix string and stack is still empty. And rule 1 is used. Next is minus. So this minus has to be encountered. So we remove this minus. But as per the rule 3, if there is a operator which is encountered in the incoming string, then if the stack is empty, push that onto the stack. So that's why this minus is pushed onto the stack. Postfix string remains as it is 7, and this is our unprocessed infix string. So next we have is bracket, this left bracket. So as per the rule, which is rule number 2, if a opening bracket is encountered, every time we have to push that onto the stack. That's why this bracket is pushed onto stack. Rest remains as it is. Then we have operand, which is 2. So 2 is encountered. So as per the rule number 1, which says that when a operand is encountered, we have to push it to the end of the postfix string. So that's why 2 will be added to the postfix string. Next we have multiply, which should be processed. So multiply is an operator. So rule number 3 says that if an operator is encountered, we have to identify this a operator which should be present inside the stack, which can be popped out, and this incoming can be replaced with this. So there is no operator inside this. We have only this bracket. So when this incoming bracket or opening bracket is encountered, we have to just directly push that operator, which is multiply here, onto the stack. Because there is no other operator here in the previous case, which is showing the status of the stack. There is no operator here. So we have to just directly push this operator onto the stack as per this rule number 3. Next is our operand, which is 3. So as per the rule number 1, the operand is added to the end of the postfix string. So it should be rule number 1. Okay. Then we have plus operator. So as plus operator is encountered, so we have go to the rule number 3. So rule number 3 says that if a operator of higher precedence or equal precedence is encountered, we have to swap them and move the operator, this multiply, from this to the postfix string end, and the incoming operator, which is plus, it should be added to the end of the stack. And we have to keep on removing the operators until unless this opening bracket is encountered or any other rule applies. Next is our 5 operator, which is on operand. So operand is added to the end of the postfix string like this after this multiply, rule number 1 again. Then again, this closing bracket is encountered. So rule number 4 which says that once this closing bracket is encountered, we have to pop the operators from the stack and add them to the end of the postfix string. So plus is popped out, add it to the end of the postfix string until unless we find a opening bracket, and we also have to remove this opening bracket from the stack. That is the rule with this closing bracket in case of evaluation as per rule number 4. Next is multiply. Multiply is again an operator. So operator of higher precedence can be popped out, but minus is of lower precedence. So multiply will be added to the stack like this. Okay. Rest remains as it is. Next we have opening bracket. Opening bracket is directly added to the stack as per rule number 2. Okay. Then we have 8. 8 is an operand, so it is added to the end of the postfix string. Then we have minus. So minus is an operator, so it will be added to the stack based on this rule number 3, because we don't have any other operator to be popped out from the stack. Then we have this 4, which is an operand, so it will be added to the end of the postfix string as per rule number 1. Then we have this division operation. So division is basically removing a operator of higher or equal precedence, but we have minus inside this stack, so it will be directly added to the stack. Okay, rest remains as it is as per rule number 3. Then we have this 2, which is an operand, so it will be added to the end of the postfix string as per rule number 1. And then we have this closing bracket. So as per the closing bracket, we have this division and minus popped out of the stack and one by one added to the end of the postfix string like this, these ones. Okay, and after that there is one more rule left, which is rule number 5, which says that when this infix string is empty, then we have to pop the operators whichever left inside the stack and add them to the end of the postfix string. So multiply is popped out first, then minus is popped out, so it will be added to the end of the postfix string as per rule number 4 and 5. So this is how this complete expression is being evaluated to resulting postfix string. So we can see this 723 multiply 5 plus 842 division minus multiply and minus is being output of this particular conversion. Next we have some practice questions which you can try out, and the outputs are also given. So you can evaluate this, and this. Will be getting these type of outputs. You can verify yourself. Okay. Once you remember that particular algorithm step by step, then it is very easy to convert this particular input into the required output without even drawing that previous table. Without even drawing this complete table, we can directly convert the infix to the postfix expression, even if we don't apply this. But in examination, sometimes in some organizations, when we give some written examinations, this previous chart has to be drawn. Maybe rule is not required, which rule you are using, but this can be the required part. Postfix string, stack, and the string in which we are going to process the infix string. So this is how we are going to evaluate it. These are some practice questions which you can try out. Thank you.